Hello, welcome to the interim presentation of Group 16. Today, we will be presenting an analysis and redesign of a simple table lamp. Table lamps enable localized lighting. Due to the flexibility of their design, they can be oriented in a number of directions. This will help increase their range effectively. They find application in houses, offices, schools, to name a few, and these would be our primary customer groups. Some research groups may be carrying out research on table lamps to help optimize their illumination and energy consumption, and these would form our secondary customer groups.
To identify important product functions, we created a FAST diagram. The task function is to create light. The primary basic functions are to redirect light, expand range, and ensure stability. The supporting functions focus on ensuring safety and increasing ease of use.
As we can see from the function component mapping matrix, several parts serve only a single function. However, some key components such as the base, vertical axis, shade, and the middle joint have both primary and secondary functions. Let's take the case of the base. The base's primary function is to provide stability. However, its secondary functions include protecting connections as well as preventing electrocution.
Here we have two possible assembly sequences for our table lamp. Due to the nature of the design, it is difficult to break into multiple sub-assemblies, meaning that both sequences follow a fairly sequential assembly process. Sequence 1 follows a bottom-up process, while Sequence 2 is top-down. For the assembly sequence analysis, both sequences were scored based on a number of factors. Both sequences scored low in the ease of testing sub-assemblies and assembly in parallel categories, as it is difficult to break the product into multiple sub-assemblies. Sequence 1 scored higher in ease of locating parts and ease of fastening and joining. This is because Sequence 1 adds the smaller accessory parts in one step, while Sequence 2 breaks up the process. From this analysis, Sequence 1 is the better assembly sequence.
Let's move on to the DFMA chart. As we can see, most of the parts fall under the low-cost, high-functionality category. Therefore, the product itself seems to be fairly optimized. However, three parts, namely the shade, base, springs, seem to have high costs and high functionality. Therefore, we should apply the principles of DFMA to these parts in order to help cut costs.
This is the bill of material for the existing product assembly. The total amount is roughly $15 per unit, which is approximately 50 to 60% of the retail price. A couple of things to note are that the most expensive parts are the injection molded base and shade, as well as the steel springs, which together account for just over half the manufacturing cost.
This is the exploded view of the table lamp. All the parts are labeled, and those repeated parts are labeled only once. The order refers to the BOM. One thing to notice is the middle joint spring is in a dumbbell shape, which is extremely hard to be inserted in that slot. Further improvement is necessary.
As mentioned above, our primary customers consist of residential and commercial users. They would primarily be looking for a product with increased flexibility, adaptability, and expanded range. In order to provide this, we would be looking to modify certain key components in our product, namely shade mount, the top joint, and the middle joint. We believe these will provide the extra flexibility necessary to increase its range and increase its versatility.
The redesign for secondary customers will include a material change to the lampshade to test how it affects the heating of the lampshade, light distribution, and energy consumption. This lampshade can be easily changed with a shade mount, as shown in the exploded view.
Let us now take a look at the product differentiation table. By looking at this table, we can see that most of the functions of the table lamp remain common to both customer groups. However, they seem to differ when it comes to three primary functions, namely their needs for changing orientation, focusing light, and varying illumination.
Moving on, we have the component commonality table, which shows the platforms and modules based on the function component mapping matrix and function differentiation table. Note that the modules listed are parts that address the functions that are different between customer groups.
The differences between our product only occur in a single sub-assembly that is attached to the main structure of our product. As can be seen in the diagram above, this allows us to significantly delay the differentiation of the primary and secondary products until the end of the assembly process, and reduce assembly costs. Given our current design, this is our ideal assembly sequence.